Oh hi, didn't see you there. Professor Elijah here, and welcome to my video. So today, we're gonna be talking about the number one thing that builds me up and mostly makes up everything that we see right here. And those, my friends, are atoms. Now, I'm gonna teach you everything you need to know about atoms. So, what are atoms? Well, according to scientists, myself included, atoms are the basic unit of matter. So, what is matter? Matter is everything we see. It can be this spoon, this laptop, or even you. Because you are made up of molecules and you take up space. So you matter. Random fact. Did you know that the word atom came from the Greek word atomos, which means indivisible? Now, if you mean indivisible, it means it cannot be cut in any way. At least, that's what the previous scientists thought. Boy, were they wrong. There is a common misconception that an atom is the smallest particle in the universe. Well, if you think like that, then you're wrong. They're actually smaller particles, like the subatomic particles, which are namely the protons, electrons, and neurons. Moving on. Now that you know your protons, electrons, and neutrons, I'm gonna familiarize you with a few words which are namely the strong nuclear force. Now, what is the strong nuclear force? Well, it's a force that binds your subatomic particles in the nucleus. Now, if ever your nucleus increases, it will stretch and it will weaken. And when that happens, radiation will occur. And we all know that radiation is a big no-no. It's bad for you, it's bad for me, it's bad for everyone. You see, radiation is dangerous because these are expelled subatomic particles. Now, there are three types of radiation. We have your alpha radiation, which produces alpha particles and said to be the weakest among the three. Then we have your beta. Beta radiation produces beta particles. You know, they're quite stronger, but they can do some harm if you expose too much. And lastly would be your gamma radiation, which has gamma rays. Now, in those gamma rays, there's this thing called photons. Photons are your energy for the element of light. Now, imagine being exposed to something like that. It can burn your skin and will definitely harm you, your health, and maybe even kill you if exposed too much. So, just get easy with radiation, just step away from it, you know? Better safe than sorry. Now, you would be wondering, how did all of this start? Where did the idea of atoms begin? Well, I'm gonna give you a quick rundown and a trip down memory lane. You see, it all started with my Greek friend Democritus. You see, Democritus is a Greek philosopher that had this idea about matter. See, he thought, what would you call this? You know? And then for the idea of atoms, you know, that build up matter. After Democritus came another boy with the name of John Dalton. Now you see, John here made the first atomic theory. Now, he has 4 statements about an atom. The first one is that atoms are tiny little indivisible balls. Number 2, atoms of the same element are always the same. Number 3, atoms of different elements have different atoms. And number 4, compounds are formed by combining atoms. So the next person to contribute to the atomic theory timeline is J.J. Thomson. Now, your boy J.J. discovered an electrons. That's right, he was the one who discovered it, proving that there are smaller particles than an atom. Now, you might be asking, Professor, how? Good question, because I'm gonna tell you. Based on what I've searched, J.J. Thomson used a cathode ray tube that has a negatively charged demonstration to show that it will separate when he turned it on. Oh yeah, the next person to contribute would be Ernest Rutherford. Now, Ernest here is a close friend of mine. He was the one who designed the solar system model, which looks like this. Pretty amazing, huh? He was also the one who discovered the nucleus, and come on, he was the one who discovered everyone's favorite subatomic particle. Let's face it, we all love the proton, since it's a positively charged and we want positive vibes all around, even though we're sad. So after Rutherford came Niels Bohr. Now Niels Bohr here, my boy, reinvented the solar system model. Now, he also discovered electron shells. Now, electron shells are those found outside the nucleus. This one. Take a look. See, those, my friends, are the electron shells. It's the outside part of an atom around the atomic nucleus. Neat. So after Niels Bohr, we have James Chadwick. Now, James Chadwick here discovered neutrons. Pretty amazing, right? And the last one is the modern theory, where they don't follow Rutherford's or Niels Bohr's style of model. Rather, they have this thing called an electron cloud. Electron clouds is where your electrons and other subatomic particles go, while the nucleus is still at the middle. They freely move inside compared to the other models, which have this circular formation that they have to follow, which they go in an orbital way. And there you go. There goes for our video for today. You know, science is a very complicated and broad subject to teach. Like, there are a lot of things to consider when taking on this. For example, chemistry. There are a lot of things to think about here, like the periodic table, your elements, chemical nomenclature, and many other. We can talk about those, but the thing is, it's fairly difficult to explain them to them without showing any visual representation. But the aim here is to show you, or to give you knowledge about what atoms are and how they came to be atoms. You know, if you ever had those thoughts, then I may have helped you. You know, if you learned something new, or maybe I refreshed your memory about this certain topic, well, thank you. No, this is just a really fun thing to talk about, where you can like explore and tell others of what you know, and then we can share some information. No? So that's it. That's the whole video, and I'll be seeing you guys next time. Hope you have a wonderful day.